Good afternoon. Today we'll see how this linear programming problem solution will be done through Excel solver, because last few classes we have seen how to get solution of LPP through graph methods, through simplex methods. Also we have seen in my previous slides, I have shown to you how to formulate the LPP, because when any problem arises in the research area or any point of time, always first of all you are converting the theory or converting the problem into mathematical model. Once a mathematical model done, the next part is, as per the data or as per the variable you have taken, and as per the number of variable you have taken, you have to decide which method is suited to that, whether graphic method or whether simplex method. Because graphic method always it has some restriction, it has some constraint. It cannot be used always, because when you have a two maximum variables, addition variables, then graphic method is used. But the moment any problem carries more than two variable, two addition variable, then graphic method fails. And usually in the big business problems, you cannot think of only two variables. Always it happens more than two variables. Then you are going for simplex methods. As I've shown to you in different tables, when solving the LPP, linear program problem, by using simplex method, or else reverse simplex method, or else dual simplex methods, always through table it takes much time to solve. Even also if you go for graphic method, we are going for some graphs. Then first of all, we are converting all the inequalities to equalities. Then we are going for making equation, and we are getting equation by converting inequations to equation directly in graph method I am talking about. Then taking the point value of x1, x2 or xy, we are able to form the lines in the coordinate axis. Once able to form the coordinate line in the coordinate axis, then like this, let me show you can understand it. In a graphic method like this, you are taking the coordinate axis and you are considering the first quadrant. Y, this is first quadrant, this second quadrant, this third, this is fourth. First quadrant, all the values of the variables, whether talk about x or talk about y, this is usually this x, this is what? Y. We have taken the variable x and y. The value of the x and y is here positive as well as 0. 0 means origin, and here both side of the x and y axis is positive. Here it is negative, positive. Here it is both are negative. Here one positive, x is positive, y is negative. So you are taking always the first quadrant. Why? When the linear programming says the last part is a negative constraint. Whatever the constraint you are taking, always it should be either positive or it should be 0. That is why we take first quadrant. Also, the taking this in first quadrant and solving it, forming some lines like this or like this, like this. Let all our approaches towards origin less than or equal to 0. Then you are finding this area is a required portion, this portion. Sorry. This portion, this to this, to this, to this, and to this. If all are approaching towards, less than or equal to 0 towards origin, because all have to move towards origin, I have told you. And here we will be getting how many vertices? Now O, A, B, these are the vertices C, D, E. Let me show. These are one of the vertices. 2, 3, 4, 5. 5 corner point coming for this feasible region. And these vertices value you have to find out. Then you have to put in z values. We have to put in Z value for each one is vertices, and the question given a maximum, which one maximum, that is answer, and which question given a minimum, then you have to find like minimum values. But this takes some time. Why not directly we can put the Excel sheet where easily you can get the solutions. No need to find everything. Let's see by the slides. What is the use of this? Because MSL Excel server is one of the widely used tool for solving LPP by academician as well as practitioner in real life. Excel server is easy to use and interpret the results. This solver has been in use for solving LP as well as 1960s, from the days of computer application of business decisions. The day you have started the using of the computer applications or use of computers. So use of computer and solving business decision, where if you have a problems in LPP, linear program problems, from that day you have started solving this problem through Excel sheet. So there is a requirement of Excel solver where you put all the data in the form of objective function, you put all the data in the form of subjected to constraints, and you put non-negative constraint, everything. Then you have to go to the top Excel solver and you can read, because your objective is to get the value of the variable as well as the total values. Like if a question given max z is equal to this, subjected to constant this, and non-negative is x1 comma x2 greater than equal to 0. So your objective is find out such a function where the function of expression of form z, this z function should be a maximum value. It should create a maximum value. If it is going to create a maximum value of z, then what should be the value of x1? What should be the value of x2? Where the coefficient of x1 is known to you, coefficient of x2 is known to you. It may be cost, cost cannot be because maximum is given. Obviously, it will be revenue or profit or sales or production, something like that. But that will be given in the theoretical part. Because from the theoretical part, you have converted this model. So here, for each unit, the benefit, each unit of x1, it is given the values. Profit or sales, usually profit or values in the form of rupees or any currency. So here, for example, if you talk about profit, so each unit of x1, the profit is 2.80. Each unit of x2 product, the profit is 2.20. Like this, if you are producing x1 number of unit, it will be 2.8 x1. And if you are producing x2 number of unit of second items, it is 2.2 x2. But as a manufacturer or as a seller, always will be expecting the profit from both. From first as well as from second. So combining, you have taken max z is equal to 2.8 x1 plus 2.2 x2. But whereas the subjected to constant given, x1 value whatever you take, no wrong, because x1 value should be positive 0 written in below. x1, x2 value should be either positive or 0. But again, the expression given as per the data here not shown. Data will be given theoretically or by you go to that area where you are creating the problems. It is still like 20,000 unit of this x1 item is present. So you cannot take more than that. That is why x1 less than equal to 20,000. Whatever the x1 value you take, positive values are 0. Nothing you are taking or wrong. Number of unit you take, but that should have a boundary. You cannot cross the limit of 20,000. Similarly, x2 values, though it is more than 0 or equal to 0, but again restriction given, it should be less than 40,000. When you are getting the solution of value of the x1, x2, of course it will come within 0 to 20,000 or x2 value 0 to 40,000. Again, there is another third restriction given, 0.003 x1 plus 0.001 x2 less than equal to 66. And the addition of this into this, this amount of x1 plus this amount of x2, you add in such a manner where the value should be less than equal to 66. Either it will be 66 or this is a maximum boundary. Similarly, each unit of x1 plus each unit of x2, you take at any moment, but the value should be less than equal to 40 per thousand. Finally, this is called non-negative constraint. It is always given like this way. x1, x2 always should be greater than equal to 0. So the solver, see, while you are solving it, solver directly, if you put the values, automatically the answer will come. No need to go step by steps. Directly you put all these values in the form of Excel sheet. You go to Excel server, which you will see in today, end of this session. What will be the value of x1, what will be the value of x2, and what will be the value of, like in this case, what is the value of z? And here two decision variables are taken, one is x1, one is x2. So x1, x2 value should you have to will find out by using Excel server. Now, and you know, graphic method is difficult to use, as I said, when the number of decision variable is more than 2. This is the demerit or limitation of the graph methods. Then LPP with more than 2 decision variable are generally solved by simplex method. The simplex method is one of the efficient method to solve LPP. But we'll see it why to simplex, why to graph. This 2 variable or more than 2 variable or any number of variables. Put in Excel sheet because it cannot be infinite. When you're solving any business problems, always the number of variables should known to you. So directly you put it to the Excel sheet and you can get the result of this. Check when you are solving this question given and it asks solve by graphic method, how you are solving it. The first up you are converting, because this part portion we have done previously, but I am just recalling this part. Now you see the similar questions, how to solve Excel server. See, this is given like this, x1 less than equal to 20,000. First up you are converting equal, x1 is equal to 20,000. Second constant given x2 less than equal to 40,000, so directly you converted x2 is equal to 20,000. Now 0.003 times of x1 plus 0.001 time of x2 less than equal to 66, it is given the questions. So first you make it equal, y need to form the point. Once you get the point, you can get the line. Now once you get the line, I have shown to you my first slide, you can get like this. Once you get the line, put in coded axis, you get a particular region where and the answer can be reached. Here one is what x1, this is x1 axis, this is x2 axis. The x1 value should be less than equal to 20,000, so you have to take a unit like looking the value of x1, x2 as it is 0, so you can take like 5,000. Then you can take 10,000. So what you have to write is in x1 axis, 1 centimeter is equal to 5,000 unit. 1 centimeter is equal to 5,000 unit. But here you look at 20,000, like this you can take 5, 10, 15, you can take 20, you can take 25. Like this, similarly x2 value should be less than equal to 40,000 given. So at least the 40,000 should be there, like you can take in x2 axis. Again, 1 centimeter is equal to like 5,000 unit. So 5, 10, 15, 20, 25, 30, 35, 40, like this you can take. Then as per requirement you have to take. For example, x1 is 20,000. So 20,000 means what is 15, this is 20. So put a line here. This is called x1 is equal to 20,000. Sorry, 20,000. So always you have to remember in notebook, all the values of x1 are 0 in x2 axis and vice versa. All the values of x2 are 0. All the values of x2 are 0 in x1 axis. Okay. And in the third equation, 0.003 x1, 0.001 x2 given 66. Like this, you can take the value of x1 0, x2 x1 0, you can get the value of x2. Similarly, you take x2 0, you can get the value of x1. That point you take and join it, you can forward the line. Excuse me. Like it's given the same ways. Finally, you got this graph where the region is this one. You got this equation, this to this, to this, to this, and to this. How many vertices you got? Now 1, 2, 3, 4, 5, 6. O is not 0. Though it is origin, the name taken O, A, B, C, D, E. How many vertices? 6 vertices. There are 6 vertices. We are finding the value of Z. Let's see here. Z at O, Z at A, see Z at A, Z at A at point A, Z at point B, Z at point C, Z at point D, Z at point E. Z at point O is 0 always. Why? Because in origin always the value of x1 and x2 always 0. Origin stands for 0. No value exists for both the values, both the variable values. Similarly, at A, the point value is 0, 40. But at this point, I told you any values on x2 axis, any values of x1 on x2 axis always 0. If it is at this point, I mean, you have to write x1 0, but x2 40. Like in this case, 20 written where in x1 axis, and all the values of x2 are 0 on x1 axis. The point will be 20, 0. The E point is 20, 0. A point is 0, 40. You can say A point is 0, 40,000. E point is 20,000, 0. 20 means 20,000. And here 40 means 40,000. And other values you have to find out. B, C, D. If you are using graph paper, directly it can be known. Otherwise, you have to find in this way. That point is the intersection of which two lines that you have to define. For example, B point here is the intersection of two lines. One is x1 plus x2 is equal to 45,000. And the another point is x2 is equal to 40,000. The x1 plus x2 is 45,000 and x2 is 40,000. If x2 is 40,000, what is x1? 5,000. The x1 5,000. What is the point values? x2 is 40,000. These are point values. I mean the point value of point B is 5,000, 40,000. You can check 5,000, 40,000. Similarly, the point value of C, point value of D, the same ways you have to find out. Like point value of C, how to get? The point value of C point value is the intersection of this line and this line. This line means 0.003 x1 plus 0.00 x2 is equal to something given. And this line is x1 plus x2 45,000. Both you solve, automatically the value of x1 x2 will come. And the value will come like this: 10,500, 34,500. That's good. Similarly, the point value if you talk about D, the point D, this one, the intersection of this line and this line. This line means it is given. This line means x1 is equal to 20,000. x2 is equal to x1 is equal to 20,000 given. So putting the value of x1 20,000 in this equation, Whether the other equation is what? 0.003 x1 plus 0.001 x2 given 66, 2066, but x1 is 20,000. If x1 20,000, put here, automatically x2 value will come out. So which is given x1 20,000, x2 will come 6,000. If you put it, automatically the value will come. And this value will put in the z function by which you got 0, 88,000, 1,02,000, 1,05,300, 69,200, and you have seen it, 56,000. But the question asks about maximum. Now in this table value you have to check which one is maximum. The maximum is 1,05,300, where the x1 value is 10,500, x2 value is 34,500. Your objective is to find the value of z, where x1 find the value of z which is maximum, and if it is maximum at what? I mean, where it is maximum, what is the point value of x1, x2 in that place, that you have to write. So here x1 is equal to 10,500, x2 is equal to this one. So at this point, x1 value is 10,500, x2 value is 34,500. Similarly, there is another question given in the minimization form. So here both are same, the format remains same, but at one place you are getting is maximum and at one place you are getting minimum. First you have to convert all the inequalities to equalities, same format you have to follow. Once you convert the inequality to equalities, you got equation. Then by choosing the value of x1, we get the value of x2, we'll form a point. See how it has done. Like this way. Choosing the value of this is perhaps x1, or this is x1, x2. So taking the value of x1, x2, automatically the value of z will come. Always at origin the value of x1, x2 is 0 as well as z value 0, because z value depends on x1, x2. When both are 0, obviously z value will be 0 because z is the 20 times of x1 plus 40 times of x2. Similarly, at a place, at a point, the value of x1 is 0, value of x2 is 18. So you got 720, you got 280, you got 160, this is 240. The origin is not considered among all these values, which are minimum. The 160 is minimum. And our objective was to find the value of such a value of z, but it should be minimum. The minimum value of z you got here is 160, where the x1 value is 4, x2 value is 2, but it occurs at the point C. It can be location, it can be any business point, and it may be, but the name is given C. So at point C, the value of x1 is 4, the value of x2 is 2. The same thing written. x1 is equal to, check, 4, x2 is equal to 2, and the optimal of z is 160. How step by step are solving it? First of all, we are converting in equations to equations, because here it is given converting all the equations to equations, and finally got this is the value of z, where it is minimum. And at that point, the value of x1 is 4, x2 is equal to 2. But now we'll see, taking another question, how do we solve through Excel solver? Let us see it. Excuse me. Now here this function given, from a business problem, we are able to convert to mathematical model, as it talks about profit, so we have kept in this way, maximize z is equal to 450 x1 plus 600 x2. The 450 time of x1, 600 unit of x2. I mean here, the 1 unit of first product or first item giving the profit 450 rupees, let 600 means, if you talk about rupees in the form of currency, rupees, then 1 unit of x2 is giving profit 600 rupees. And the combined profit will be 450 of x1 plus 600 x2. And for this we have a 3 constraint on plant P1, constraint on plant P2, and also there is a demand constraint on the fertilizer A. So all the things are given like this way, and the non-negative constraint x1, x2 is equal to 0. This is the model. So here the coefficient matrix talks about 5, 3, like here in the same way as you have tried. The matrix is what? 5, 3, 4, 9. This is 1. This is 1, of course, will be 0. When the value is absent, you have to behave or you have to consider this as a 0. What is cost matrix, or you can say coefficient matrix in objective function? It is 450 and 600. This is A. What is X? Next is here x1, x2. As I have said to in the previous slides, always is a column matrix, or you can say this is called a variable matrix. The variable matrix name is capital X, where 2 variables we have taken. One is x1, second is x2. See the difference here. You are writing non-negative constant x1 and x2 value should be positive or 0. But here in the constant is given, whatever the x1 value you take, no wrong, but it should be less than or equal to 20. It should not exceed the value 20. Check. It's given clearly x1 less than or equal to 20. But here you are writing non-negative constant x1 should be more than or equal to 0. x2 value should be more than or equal to 0. But when the restriction given x1 less than or equal to 20, the x1 max to max it can move up to 20, not more than 20. More than 20 is not allowed. So that constraint you have to keep in mind while achieving the objective function as the total profit as a maximum. So you have to keep in mind that the number of unit of x1, the first product, x1, because x1 is linked with first product, x2 is linked with second product. The third constant says demand constraint, which is on fertilizer A. Whatever you take, no wrong, but it should not more than 20. Either it should be is equal to 20 or it should be less than, but more than 0. Now coming to solver, always you have to you should have the facilities for the using 2007 or latest version 2019, whatever the Windows, but the solver, Excel solver should be there in the data. So first of all, you have to put this data, the problem is given to you in the Excel sheet. At any cell you keep no wrong, but you have tried objective function. Whatever you have done in theoretically is what you have written. Z is equal to this and subject to context like this. All these has to be pasted in the Excel sheet. Where you put no wrong, but wherever the formula you are using, that has to be defined. Like here if you check, it is given, see these portions, 450 into 1 plus 600, 450 x1 plus 600 x2. Check, it is given 450 x1, 600 x2. So just you put it in the Excel sheet, objective function. See the constant, what it is given, 5x1 plus 3x2 less than or equal to 150. So 5x1 plus 3x2 and then return. But this is the main part. This is the main part. When we are converting to mathematical solutions, because as you know, you have a 2 decision variable. So in A1 cell you put x1, second cell you put x2. Then here 2 cells you have highlighted in the yellow mark. Here I have taken yellow mark, you can take any other marks. You can take green, but that you should know what is the meaning of these two cells. When you are highlighted by any color, you should know the meaning of this. These two meaning says what is the number of x1 unit, what is the number of x2 unit. Will produce by which the profit will be maximum. And these are property functions, 450 x1, 600 x2. So here 450 written, 600 written. So 450, this is x1, 600 x2. Then the objective value will be 0. How it will be 0? Because initially the decision variable will have nothing. x1 value is nothing, x2 value nothing. So 450 into, just a minute, like 450 x1. If I am not taking any value of x1, it will be 450 into 0 plus you are not taking any value of x2, it will be 0. So 600 into x2. If x2 value nothing, so the total value will be 0. That is why this objective value is 0. But I will show you how to define through Excel sheet these objective functions. So let's see it clearly, clearly this screen. After this, I will go for direct Excel sheet. I will show you how through Excel sheet the problem is solved. Here the constant same thing written. The coefficient matrix 5. All the x1 coefficient is 5, 4, 1. So it is 5. Just a minute. So this coefficient is 5, 4, 1. So it is 5, 4, 1. The x2 coefficient is 3, 9. But in third constant x2 value is absent. So 3, 9. Third constant value is absent, so you have to make it blank. Then initial the value will be 0. Just remember it how it is 0. I will show you later on in the slides directly. This value is 0. And here the symbols are given less than equal to y, because for all the constant it is given less than equal to. But if any symbol given in between greater than equal to, you write greater than equal to. If it's given is equal to, you put is equal to. That option will be there in the Excel sheet. That I will show you. And this is the right hand side. V matrix, product matrix. 150, 180, 20. So 150, 180, 20. And how this will be, we'll see, by the Excel sheet, how this particular box will come. Everything I'll show you while solving through Excel sheet. And this is the solution part. End of these solutions, we will be getting x1 value will be 20 number of unit, x2 value will be 11.111 unit, and the profit, it is given objective function 450 x1, 600 x2. The final total profit will be 15,666.67. But these are the data given 541,390. These usage unit also will come, and this is given. So finally, you will be getting x1 value is 20, x2 value 11.11, where the total profit will be 15,066. And same thing written, final value will be 15,666.67. But let me show it detail through Excel sheet. See, we have shown by the table how it has come. The same thing I will show through Excel sheet. Our objective is, what is the value of x1? Let you are taking two variable. In the objective functions or in the business problems, you have taken two variable, decision variable. So our objective always will be the value of z should be maximum. And if it is maximum, then at what point it is maximum or where it is maximum, that you have to find out. I mean, what is the value of x1, what is the value of x2? That is the main objective. But then three variable the value you have to find out. Let us see the Excel sheet. So this Excel sheet I will show you now. This taking another example. Similar ways you can link. Let us write here objective function. Let objective function is your 5x1 plus 6x2. From any business problem you got, you have taken two variable, decision variable x1, x2, and the profit. Just a minute, objective function. Match z is equal to max means maximize z is equal to 5x1 plus 6x2 subjected to constraint that is given 2x1 plus x2 less than equal to let 100 x1 plus 2x2 same inequality you take. Let us start with first all are less than equal to. The same ways you can convert if it is greater than equal to wherever I'll show you. Then place of less than equal to you can take greater than equal to. Let us take a simple example first. Let 150. Right, two constants given. Let's start with two constants first. The last one is non-negative constraint. x1 comma x2 greater than equal to 0. We have got to symbol greater than equal to insert it, close 0. But this is the question. You got from the business problems this model. After converting to mathematical model, you got objective function is maximize it, where it is 5x1 plus 6x2, subjective constant 2x1 plus x2 less than equal to 100, x1 plus 2 less than equal to 150. So here the limit is, here the constant is 2 times of x1 plus 1 time of x2 combining you take, but it should not exceed the value 100. Similarly, 1 time of x1 plus 2 time of x2 less than equal to 150 should not exceed 150 units. And finally, as you know, non-negative constant always either should be 0 or should be positive. It has to be put in a double form. Then you see at what point the value of x1 you have taken such a manner where the z value will be maximum. So right here x1 first here. x2, we are requiring this value should be, what is the value of x1, x2? So put it in yellow color, but you require the value of x1, x2. Right? Now, take this cell. Okay, you got, just a minute. Right here, the objective function value is, you have to write in this way, 5, is 6. You write here x1, this is x2. Let here you are finding the value of objective functions. So I have right here is equal to sum product of it is 0. Why? Because we don't know what is the value of x1, we don't know the value of x2, which we are going to find out. So we have to put the formula is equal to sum product this into this. Why this sum product? Because we have multiplying as well as we are adding 5 into this plus 6 into this with addition. That is why it is 0. Now take your constraints. So here you got 2 of x1, this is 1 x2, here this is 1 x1, this is 2 x2. Now the constraint is the sum of this 2 times of x1, 1 time of x2, it should not should not exceed 100. So right here first put the symbol which you are going to use, insert, go to symbol less than equal to, and copy this symbol, why you are copying it? Because in both the constant is given less than equal to, so directly copy it or you insert it, and here the values are 100, this is 150. Now here you have to create the formulas about the constraint, because always I'll show you by the solver, always left hand side should be compared to the right hand sides. So here the 2 times of x1, 1 time of x2 less than equal to 100 given first constraints. Then what is the value of x1 is unknown to you? What is the value of x2 is unknown to you? To create the same formula is equal to sum product this cell, copy this shell, this value will come, automatically the number of column row will come with multiplication of this column. Similarly, here do the same thing, is equal to sum product so here this constraint with the value of x1, x2 which is unknown, both has to be selected. Initially both will be 0 because the x1, x2 value is unknown to you. And once you use this solver, automatically the value of x1, x2 will come, where the value of z will be maximum, and also x1, x2 value will come out automatically. Now once you did this, see at the side, by the side I have not written anything, because as per the problem you have write. For example, you are using two machines, let a grinding machine and let polishing machine. So here you have tried grinding, polishing machines with the time constraints in the form of hours, right? And the objective function is given always given the form profit, Because I have put a mark here, it can be profit, it can be sales, it can be production. Let you think this quotient talks about profit. Then, once you able to write all these objective functions in the form of this way in the Excel sheet, then directly you have to go to the Excel solver, go to data, solver is here, this image will come, put it to one side, then first given set objective. Your objective is what? The value of Z should be maximum. So first click this cell, this one, because this is your objective. Initially it is 0. So which is okay. Then click here. Now it is given to maximum, minimum value of. When the objective function is given maximum, you have to select maximum. By default it is selected. If it is given minimum, you select minimum. But here the question, your objective is to have maximum value of Z. The maximum you have to select. Then there is another box you can get by changing the variable cell. Whatever the variable you have selected, additional variable, that has to be taken here. That has to be selected here. So this is your part. This one. As you click here, then you select it. It automatically be selected. Then come to this, subject to the constraints. Then focus on the constant part. So this is left hand side your add. In cell reference, left hand side will be there, in constant right hand side will be there. This is your left hand side. Select it. See here, less than equal to, is equal to, greater than equal to given. Integer difference is given, you require less than equal to, so you select it. But if you feel both are given greater than equal to, you choose greater than equal to. Then come to constraints. Constant given, it should not exceed 100, it should not exceed 150, so both you select. Why both you are selecting? Because both are given less than equal to. So directly put here. Now okay. See, everything is there. Now you are going to solve by simplex method, linear programming. So it is given GRG non-linear, it is non-linear, it is linear. So linear LP you have to choose. Also you are not looking evolutionary, it will be simplex LP. Then you go to option, solve. Okay. Let's even keep solver solutions. Answer, sensitivity, limit, you take answer. Then go to okay, check. The solution come out. You got here 16.66 time of x1, 66.66 time of x2. So you can make it round, where the profit will be 483.33 rupees. Talk about the given rupees form, that is 483.33 rupees. So this way, any question can be solved. Like if you choose another one, same way you can take. If you are taking three variable x1, x2, x3, so you can take x1, you can take x2, you can take x3, and again you choose this in the colors, yellow colors or any other colors. Let the objective function given 50x1, 20x2, 30x3. This you take. Let the subject to constant given, like you see the previous one, is given 2x1 plus x2 less than 100. So you can take another one like Let 5x1 plus 3x2 plus 4x3, okay, let the symbol given greater than equal to 100. Similarly, 2x3, 4x2, 7x3 given less than equal to 500. Let this is given. Then find the value of z where it will be maximum. I mean, you have to find the value of x1, x2, x3 at any point where the value of z will be maximum. Right? The same way as you do, same ways you have to follow. As you create the objective function, where the objective function maximum, to put a box right there is equal to sum product select it, G5 to I5, comma, and select it, sorry, therefore is equal to sum product with comma, select this, here same is equal to sum product comma, select the variable. Now you have to go to the solver. Data, solver. First set your objective. Objective mean given or max given. Max given. But first of all, you have taken this objective function cell. To click this cell, automatically will come. Then maximum is okay. Well, coming to this, choose this one, which you have highlighted by yellow colors. Then come to subjected to constraint. The first one you consider. Add. This is greater than equal to change it, greater than equal to right hand side, none, again add, again this one, select, symbol is less than equal to, choose this one, okay, so this is you got. Now go to simplex LP, then solve. Keep solver solutions, answer, okay, answer done. The total profit will be 12,500 rupees, where only X1, you will never produce X2, X3, will only produce X1 but 250 number of units. This is ways, any question coming, The same way as fast you take all this coefficient you put in the Excel sheet, then define by the formulas, like some product you have to take, where you want to get those values, then you have to use Excel solver. And finally, you can get the solution. Thank you.